28. So the first thing we would do is actually split that thing into two radicals. Now the main reason we split this one up is because 1,296 is not divisible by 25. If it was, we could leave it as a fraction, divide, and simplify. But we have this here. Now, I think some of you all turned this in. I know, I can't remember if it's this or others, but turn this one in. And I've simplified this down. Now, the fourth root of 1,296, doesn't matter which calculator we grab, is actually 6. So the numerator of this does simplify nicely. It's 2 to the third, or 2 to the fourth times 3 to the fourth, or 2 times 3, which gives us 6. Now 25 is the same as 5 squared. It's 5 times 5. Now there is something very peculiar about this problem here. The power and root, so this is the fourth root and the power is 2. They're both even. They have a common factor with them. Now on a side note, the nth root of a to the x is the same as a to the x over n. Yes? Well, for the fourth root of 5 squared, okay, let's try that one more time. Fourth root of 5 squared as a fractional exponent would be 5 to the 2 fourths. Yes? 2 fourths simplifies to what? 1 half. Yes? So really what we're saying is at the bottom of this, the fourth root of 5 squared is the same as the square root of 5. This is the only one that shows up like this. So really what we're saying here is that we have 6 over the square root of 5. Now to simplify the radical, or simplify this rational expression, we need to multiply the top and bottom by something to get the square root out of the bottom of the fraction. Well, we would need to multiply by the square root of 5. Because the bottom would be the square root of 5 squared, and the top would be 6 times the square root of 5, which is just 6 square root of 5 over 5. It's one of those that worked oddly enough that way, and it only did that simplification because the 25, the 5 squared, and the fourth root had a common factor that reduced. If it had been 5 to the third, we would have just left it and not done anything with it. Questions on 28? Pretty good with this here. All right. Any other questions over the homework before we get started? Now, this is the kind of problem we're going to look at today. Now, we actually did one of these yesterday. Yes, y'all remember doing this? I wouldn't write this down because we've seen how this works. When we have one radical on each side, it works out. It kind of gives us some interesting things and then works out that way. Yes? So, we're going to do this one here. So we've seen one where we have 2 radicals. We're going to look at one that has 3. Yeah, we're going to do this one here. Well, yeah. I'm probably using the pronoun we a little loosely, but well, we as in a group, we're going to do it together, but it's probably going to be more I'm showing you how to do this less than collectively we're doing the problem together. It's semantics. It's purely semantics. Now, looking at this here, we do have more than one radical, so we need to even them out. Now, there's no real easy way to even 3 because it's odd. So we'll just move on to step 2. We're going to put both sides to the nth power. What's going to be our nth power for this here? 2. Now, the nice thing is going to be the right-hand side because the square root and square are going to cancel. Now, I wouldn't start writing that out because we're going to have to multiply the other side out first. So, since it is 2 things being squared, we're really saying that we're taking 2 times square root of x plus 1 minus square root of 2x multiplying it by itself. And the right side is going to be x minus 4. Because we square both sides, and because there is a sign between our 2 radicals on the left, we are going to have to write this out. Now the right-hand side, since it's one term, the square root and squared are gone, giving us x minus 4. Now the left-hand side, we're going to distribute. And the first thing we're going to multiply is 2 times square root of x plus 1 by 2 times square root of x plus 1. Well, our 2 times 2 is 4. And we're multiplying it by the square root of x plus 1 squared. Because we're multiplying the radical by itself, so we are squaring it. That's all squaring is. But the square root and the square will cancel. So for us here, it's really saying that we're taking 4 times x plus 1. And we'll simplify that here in a minute, because that's really all that's saying there. Questions on this here? I'm good with this here so far. Our next piece is going to be 2 times square root of x plus 1 times negative square root of 2x. Now this will be negative because we'll multiply the numbers in front, negative 1 and 2. Well, negative 1 times 2 is negative 2. Square root. Now since the radicals are the same, we can agree on them both being square roots, yes? Now if at any point something doesn't make sense, please ask. Since they're both square roots, we multiply what's inside. So we have 2x times x plus 1. Now, yes, it is going to be 2x squared plus 2x. We will distribute it out. And I think for some of y'all feel comfortable with that. Let's leave it here. We will multiply in a minute when we do this here. Now, the reason this works is it's the same as square root of 4 times the square root of 2. When the radicals are the same, we multiply what's inside. So we're just saying that this is the square root of 4 times 2. We're just distributing that out. Does that make sense? Kind of, sort of. Next thing we're going to multiply is negative square root of 2x by our 2 square root of x plus 1. Questions? Well, this is going to be negative 2 square root of, giving us the exact same thing. And lastly, negative square root of 2x times negative square root of 2x. Negative times a negative is a positive. Square root of 2x squared. Well, the square root and squared will cancel. So this here is going to be plus 2x. Questions on this so far? Questions on anything we've done so far? Questions on how we've multiplied those two expressions together? Now the only thing we're missing is, into the next step, is this here. Can we say that those two radicals are the exact same? Yeah, they're the exact same. Negative 2 minus 2. If the radicals are the same, they're essentially like terms. Negative 2 minus 2. Negative 4. Because for all intents and purposes, we're treating those as like terms, so it's just the the coefficients, negative 2 minus 2, negative 4. At negative 2 of the square root, I'm subtracting 2 more of them from it, gives me negative 4. Questions on this here? All right. Now we need to do some simplifying a little bit, but how many radicals do we have left? 1, so we're going to get it by itself. We have to do a little more steps to get there, but we are going to get it by itself. And the first thing I mean by that is, well, we are going to need to distribute that 4 and move things to the other side. 4 times x is 4 times 1 is 4 minus our 4 square root of 2x times x plus 1 plus 2x is equal to x minus 4. Now we do have some like terms, 4x and 2x. 4x plus 2x is 6x. We want to get this thing equal to 0. So that's the first thing we can do. I would go the other way. So instead of minusing x, I would minus. Yeah. Yes, no, I didn't. That was me also. Because we do have 1 radical left. So not yet. Because we got it simplified as far as we can. Now step 3, which we've been ignoring for the most part, we did talk about it once yesterday, is there any radicals left? Well, yes. Repeat steps 1 and 2. Step 1, is there 1 radical? Yes. Get it by itself. And that's the main goal, because we're getting it by itself now. Now, once we get rid of all of the radicals, all the square roots, cubed roots, any of those, then we're going to put both sides to the nth power, square it one more time, and then get it 0. Because once we get all the radicals gone, then we'll get it equal to 0. Then we're going to minus 4, telling us negative 4 square root of 2x times x plus 1 is equal to negative 5x minus 8. Yeah. Either works. It's because it does work out that we can leave the 4 there, but it's going to be a little bit easier-ish to move it over. Because our main goal is to get the radical by itself. Did we get it by itself? No. Radicals by itself, so we're going to put both sides to the nth power. And that power is 2. Do I need to slow down? Now this time, the left-hand side is going to be nice, because the square root and square will cancel, leaving us with 2x times x plus 1. Since we have our addition subtraction signs, we're going to have to distribute this out. Let's do the bottom of the fraction first, because up to this point it's been some tricky, complicated, not complicated, it's just been a lot of steps up to this point, yes? Let's do something nice. Let's do the bottoms. -4 times -4. 16. Kind of nice when we have those every now and then. The numerator, -5x times -5x. Negative and negative is a positive. 5x times 5x is squared. -5x times -8 is plus, I think, because 5 times 8. Yeah, we will have plus 64 at the end. 8 times -5x is going to be plus 40x. And lastly, -8 times -8 is plus 64. And if you're wondering about the negative, why it completely vanished, well, -5x, -8, and -4, that negative would turn everything positive technically. But questions on the right-hand side? We are going to combine like terms here in a minute. We've been leaving as 2x times x plus 1 the whole time, yes? Let's go on and simplify it. 2x times x is 2x squared. 2x times 1 is plus 2x. Questions on this so far? We good with this so far? We can say yes for the most part. For the most part, we're good with everything we've done so far. Ever imagined back in August that we can actually say that this stuff makes sense so far? So, okay. I'm going to go to the next page. Just we're good to this point. Yes. Now that fraction, I think, is what everybody's not looking forward to trying to work with next. Yes. We can, but it would be nice to get that thing equal to 0 first. Yes. Yeah. All right, Vince. I'm going to pick on you. Do you have a suggestion for how to get rid of that fraction? Actually, take it. Huh? I know I put you on the spot, but it's actually kind of nice. Because what's on bottom? Now, we've done this with when we had, say, -x squared plus 3x minus 4, yes? With factoring, it's nice to have that x squared be positive, yes? So we'd multiply it by -1, yes? To get it to look nicer. Because if I multiply the right side by 16, what happens to that fraction? It is now gone, yes? Because now it is but if I do it to one side, we have to do it to the other. Because here the 16 and 16 cancel. Here 16 times 2x is 16 times 2x is plus. All we did was multiply by a scalar. Yep. Mm-hmm. No. No. Now, at this point, we want to get this thing equal to 0. Now, normally I would move everything from the left to the right, where I'm going to go to the right to the left. I'm going to subtract 25x squared. 32x squared minus 25x squared is 7x squared. Plus 32x is equal to 80x plus 64. Yeah. Questions on this so far? Now at this point we could try graphing it. It will give us a solution. The reason I say 1, because it will most likely give us 1, because the factors of 7 are 7 and 1. Now, if 48 and 64 had been divisible by 7, they're not, then there's a good chance we could factor the 7 out and have two nice factors. I'm going to go on and factor it with our plus and minus, since the third term is negative. Factors of x squared are going to be x and x. 7 and 1. I'm just plugging this 7 in. One of the two spots. Because again, we're just factoring, we're going to need to plug it in at one spot. Now 64 is 1 times 64. 2 times 32. 3 does not work. 4, I do not think works. Nope, I'm wrong. 4 and 16. 5 does not work. 6 does not work. 7 does not. And then we have 8 and 8. Yep. I'm going to try 8 and 8. Did any of y'all graph it? Did you get a 0 at 8? Yeah. Yes. And probably if you look at the graph, let's see here, at 0, it's negative value of y. And at negative 1, I believe it's also negative. And then at 2, it's positive. Yes? So at negative 1, it's a negative value for y. At negative 2, it's positive. So if you look at the table. So negative 1, it should be a negative y value, and negative 2, it should be a positive y value. So it's crossing between those two spots. We'll see here in a minute. Now, before we do that, I'm going to check my middle term just to make sure. 7x times negative 8 is negative 56x. 8 times x is plus 8x, giving us a negative 48x. So we have the correct middle term, we have the correct factor. Since we have it factored, anytime we have two or more things that multiply together equals 0, one of them must be 0. Either 7x plus 8 is 0, or x minus 8 is 0. Now on the left right-hand side, if we solve this here, we get that x is indeed equal to 8. Left-hand side, 7x plus 8 equals 0. Well, to solve for x, we would subtract 8 from both sides, telling us 7x is equal to negative 8. Then we would divide by 7, telling us x is equal to negative 8 sevenths. And the reason I was saying negative 1 and negative 2 because negative 8/7 is bigger, or well, less than -1 technically, is between -1 and -2. So where it crosses the x-axis is between those two values of x. But these are our two solutions. Questions on this here? Which one of these do we think is probably not going to work? -8/7. Now, second quick. -8 alpha y equals over 7. We're going to store it in as x. 2 times square root of x plus 1. 2 second square root x plus 1 is that imaginary number there. I don't even have to check the other side. It's complex. Doesn't even work. And the other one was 8. Store x. Is 6. Okay. Oh. Actually, look what we're doing. 2 square root of x plus 1 minus 2 square root of x. Okay. Let's try this again. Minus square root of 2x. 2 square root of x plus 1 minus 2 square root of 2x. Okay. So 2 square root of 8 plus 1 minus square root of 2 times 8. Now the left-hand side, when I actually typed it in correctly, we got 2. On the other side, second square root of x minus 4 is also 2. So 2 does indeed equal 2. And even the other one, and I didn't put the whole thing in, -8/7 store x is still an I. So they didn't even match up. That does not work. Our only solution is x is equal to 8. But again, the main reason that I wanted to show you this is that I really wanted to show you, not so much that to scare you or we're going to do anything other. I wanted to show you so that you've seen it. Because now we can say we've seen this, and on a whole, would we say this is so much more harder than what we've been doing? It's not significantly harder. It is a lot more steps. So the likelihood that we flip a sign, have a small error, does increase as we go. But it is possible to do these here. Questions on this here?